So now we reach the main part that we wanted to talk about, and that is the self-conjugate triangle. To do this, we want to introduce two sectoral functions that we can apply to sectoral structures. And those are, we're going to use two Arabic letters for these, Ghayn and Ghayn. So let me write those so you can, if you're not sure how to pronounce them, Ayn, and we write it like this. And then Ghayn, and we write it the same way, but with a dot on top. So the Ayn function, when we apply Ayn of An, of a sectoral structure, that means we do the following. Let's quickly also remember, this means continuous with, and this means alternating with, when we talk about sectoral structures. So this is similar to an alpha joint, and this is similar to a beta joint. So we will say 1 Ayn of An, we say 1 is alternating with An, and then is continuous with 1. So 1 alternate An, continuous 1, and then we put a negative symbol here because we're going to look at the reverse of that sectoral structure. And because we're going to add two sectors, the size or the degree of this sectoral structure will go from n to n plus 2. Let's look at an example. Let's say x of n is equal to 3 1 squared subscript 5. We say Ayn of xn is equal to 1 alternating with 3. And then we have 1 squared continuous with 1, and then reverse all of that. So this is equal to, before we reverse it, 1 alternate, so 1 3, and then we have the 1 squared continuous with 1. We contribute one sector here. This becomes 1 2. We still have the reverse. So let's reverse the order. We get 2 1 3 1 subscript 7. So that's interesting. Why did we do this? Because this turns out to be also a self-conjugate. So this is very interesting, and this might have some applications in organic chemistry or wherever you have chains of isomers in a mathematical way. So basically we started with a self-conjugate, we applied the Ayn function, we ended up with the next self-conjugate of a little bit higher degree, of the next even degree, or the next odd degree, sorry. Then we have the Ghayn of An, which is the same but with a dot on top of it. Ghayn of An will be the opposite of this. So we will say 1 continuous with An, alternating with 1. And we're going to put a plus sign here because we're not going to reverse the order. So let's look at Ghayn of 3 1 squared subscript 5. We will say 1 is continuous with 3, 1 squared alternating with 1. 1 plus 3 is 4. And then here we have 1 squared alternating with 1, so that's 1 cubed. So we get 4 1 cubed subscript 7. And this one is also a self-conjugate. So this is pretty fascinating because we have two simple rules that help us go from one sectoral structure that is a self-conjugate to the next one. And keep in mind, those are very rare. So very few sectoral structures are like that. What happens if we apply it to the sectoral structure 1 1? We will say, let's say Ayn of 1 1 is equal to 1 is alternating with 1, and then we will say is continuous with 1 and reverse. So equals 1 comma 2 reverse equals to 2 1. So Ghayn of 1 1 gives us 2 1 subscript 3. Now let's see Ghayn of 1 1. Ghayn of 1 1, we will do this. 1 is continuous with 1, is alternating with 1, equals to 2 comma 1 subscript 3. So both Ghayn and Ghayn of 1 1 gave us 2 1 subscript 3. So this was interesting here. Now what we're going to do is we're going to apply these functions downward or upward in the if we're talking about degree. So we will say Ghayn of this structure will give us this 2 squared 1 subscript 5, which is also self-conjugate, and Ghayn of this will give us 3 1 squared subscript 5, which is also a self-conjugate. We do the same, Ghayn, Ghayn, and we get 2 self-conjugates from that one. And we do this also, we get 2 self-conjugates from that one. And now we see why with each odd degree, the number of self-conjugates doubles. And that's why that formula that we saw earlier makes sense. Now we do the same here, it keeps doubling indefinitely. So Ghayn, 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 Ghayn. So each of these gives us the next set of self-conjugates. So look at this. We know that there's a very large number of sectoral structures of degree 9. And to take each one and figure out what its conjugate is and whether it's a self-conjugate takes an insane amount of time. But by doing this, we can figure out quickly the exact sectoral structures of degree 9 that are self-conjugates. Thank you.